Hello and welcome to Microsoft Hates Greg. My name is Greg Deckler, and today we're going to be probably talking about something that's fairly controversial. And then I know there's a lot of you out there like, big surprise, Greg. Like everything you do is controversial. I don't really mean to do that. This one might be a little more controversial than most, though. So hang with me here. So today I was over lunch. I was listening to this Zebra BI report optimization webinar that they held for free, and kudos to them, for having something like that. Now it was disappointing to me. It was just the same old like stuff that always gets rehashed, right? Um, less visuals and this and that kind of thing. So it really wasn't. I was kind of hoping for some more insights, some unusual kind of insights, given the whole performance optimization stuff that I'm doing around the reporting, visual layer. But there wasn't much. I didn't get anything out of it. But one of the things that they talked about, is the standard star schema versus single table data model. And they referenced this article by Marco and Alberto at SQL BI. And so I ended up like going there, and I'm pretty sure I read this article back in the day. But I started reading through this article again, and I started noticing a lot of problems, like major problems with this article, with the setup and everything. And so I wanted to recreate it, and I came to probably some different conclusions, right? But let's stick right now before we get into the flat table or single table versus star schema. Let's talk about the problems in this blog article. And the first major problem that you find as you go through this is that it's not repeatable. Okay, like I can't download the PBIX file that they used, the PBIX files that they used, and independently verify this and what they're saying myself. And that to me is a huge problem, right? Because like Marco likes to talk about content creators need to be responsible, right? We need to be responsible with what things that we're saying and claims that we're making, right? Well, to me, it's highly irresponsible to present a piece like this that's not presented as an opinion piece, right? It's presented as something that's like scientific kind of facts here, but not be transparent with it. I think that's hugely irresponsible and a problem, right? Because I inherently just don't trust authority to begin with. And then when that authority is not transparent with me, right, I trust it even less. And then when I can't independently verify what's being said, then I trust it even less. And then I find major issues with the presentation of what they did. And then I don't trust it at all, right? And so I think it's a big problem. Just number one. And none of like almost I don't think any of SQL BI stuff is independently verifiable, which then just relegates it out of, fact to be just it's some guy's opinion. All right. And maybe that seems harsh, but that's the way I look at it. If all my stuff that I do on this channel, you can independently verify it, right? I got the PBX files are all up on GitHub. If one of them's missing or something's missing, let me know. I'll send it to you, right? Everything that I do is 100%, transparent. In fact, there's going to be a link in the description of this video on where you can go and grab my PBX files, right? I'll share out a folder. I'll throw them up on GitHub. One way or the other, you can have them, right? You can independently verify everything that I'm saying, right? If you can't do that with an authority, then that's a worthless authority figure, in my opinion. That's just my opinion. So if you can't independently verify, you can't be transparent with what you're doing, then it's just a random opinion that you have. So let's get into this. So first of all, the setup. They don't explain the data model at all, and it seems like a highly contrived like situation, right? In terms of like why do you care about how heavy your audience is, right? And why do you care about how heavy your audience is in periods of increments of 5 minutes, I guess, in terms of, but they don't really say what this is. They don't explain this scenario at all. They're just like, here's the data model. Well, what is this data model doing? What are you trying to accomplish with this data model? What's the end goal, right? Or is this just a data model that you invented just for purposes of doing this performance testing? And there is no real world kind of thing to this, right? Because I don't know why you would need to know how heavy your audience is multiplied by their age, right? In 5-minute increments. That's mind-blowingly stupid to me. But maybe it is. Maybe it's a real-world thing. I don't know. But then you start getting into more problems, right? Then you start getting into, well, we flattened the data model out, right? Well, then why do you have these foreign key columns in here? And they're talking about like how big this is compared to this. Well, yeah, you keeping all these high cardinality columns around. Why are you doing that? Right? If this was really a flat table and a real example of a flat table, these would be gone, right? Because you don't need them, right? You don't need them to connect to these dimension tables. So why are these left in here? And we don't even have the full list of how many columns are in this, So there's some problems there, right? Then you start getting into where this is a 4 billion row data set. And you're thinking 4 billion, I mean, sure, they're out there, right? And Microsoft, I think they did like a trillion row data set as an example, as a showcase kind of thing, but that's not the norm, right? And the norm is probably more along the lines of like less than 50 million rows in your fact tables and that sort of this is so far skewed into like on the high side that is it even applicable to like your normal sized Power BI projects and tables and that. I mean, and here's the reason I mention this is that I've spent half of my career in consulting in enterprises, and I've spent another half in like small and medium business. And I can tell you that the amount of complexity that you introduce to a solution at an enterprise level is much, much different than what you do at the small and medium business level, right? You have to right size the solution for each. Okay, and there's reasons why you introduce, complexity is evil. We learned this as engineers, right? Complexity is bad. You only introduce it if it's necessary. And so a star schema is introducing a complexity to within your semantic model, right? So maybe that is a benefit at an enterprise scale, but doesn't make sense at a much smaller scale than that, where you're talking about thousands of rows or hundreds of thousands of rows or even just millions of rows, right? Does it apply? Like, are you gaining any benefit from that complexity? It turns out surprisingly little potentially. So anyway, so he talks about database size, and this I can confirm, and I'll show you guys. But then he starts getting down into, and here's the reason why I go back to transparency. The reason why I go back to transparency is that it's very easy to, when you're doing these types of analysis, to introduce unintentional bias, where you're not meaning to be biased, but you unintentionally introduce bias, right? It's very common. And that's why, no self-respecting scientist is just going to say, oh, this scientist said this. They're just like, oh yeah, that must be how it is. And right, they don't do that. They independently verify this thing. And I think, we in the data community need to do the same, right? Just because, somebody says something, if you can't independently verify it, then it's just that some random guy's opinion. And I'll show you a specific example of unintentional bias in this. So he goes through and does group by multiple columns, all this other stuff. Basically, at this point, it's mostly that flat tables and star schemas are basically the same speed. All right. Then he gets down to year-to-date calculations, and he says, oh, this is where basically flat tables fall flat on their face and are no longer faster or as fast as star schemas. Except Marco's not really that good at no calculate DAX code, which tends to be really good with flat tables, okay, is what I'll say. So he sticks to his kind of old school traditional calculate approach, right? And he gets bad results. Well, yeah, because that's not how you would write a year to date for a flat table data model, Marco. I'm sorry, but you wouldn't write it this way. There's other way more efficient ways to write it. And because I would say Marco is not as familiar with those kind of approaches, so he's introduced an unintentional bias into his analysis. Okay, so there's a very good example of an unintentional bias, and I'll show you this. It goes on, and values as a column, slicers basically, and presents the conclusions. But again, this is just all opinion. It's one person's, doing this, but I can't independently verify any of what he's saying here. And so to me, it's relatively worthless. All right. So, and in fact, when I try to replicate it, I get different results. And I get, true, it's at different scales, but that's kind of on purpose, right? So, does this have any bearing to real world typical Power BI scenarios? And the answer is, it doesn't. But you guys can decide that for yourselves. All right, so let's bring this up here. I've got this one, which is flat largest. So what I did, and I got star largest. Okay, so got these two going on here. We'll put flat over here. We'll put star largest. And what these are 15 million row, which I thought ends up being a pretty decent size. I think is fairly typical of what's out there. This one is also 15, same amount of rows, right? Same amount of rows in both, except that this is a star schema, right? It's a pretty typical star schema that you would find, right? And then this is order date is what this is connected to as far as the date. And this was also when I joined this all together, because I started with the same exact. So I built this first, and then I went into transform data, and then I built the flat table version of it, which is it's just a flat table, right? It's just one table. And what I did is I merged all of this stuff, all of these dimensions into it, and then expanded out all the things except for not the key columns, right? Because you don't need foreign key columns in a flat table. That makes no damn sense whatsoever. So I did that, and I'm trying to think of anything else that I did to this. It's pretty much really just about it. Now, what I did was I started with a 60,000 row fact table, which is basically the fact internet sales from AdventureWorks, right? I want to make this repeatable for anybody. So then to get up to 15 million rows, I just kept on appending the fact table to itself, right? So that doubled it, every time. So I went from 60,000 to 120,000 to 240,000, blah, 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 blah. Okay, so that's how I did this. And I did the same thing for this fact table, right? Same exact thing. Now, what I can say, I can definitely verify, is database size. So this is the star schema, and the total size is like 7 megs versus 350 in my case. So I can tell you that, right, that the memory size is much larger for the flat table versus the star table. But then the question becomes is, do you care? Right? Like, whose problem is that? Right? Especially if you're on shared capacity within the Power BI service, do you care how much memory is being consumed, right, by your data model, whether it's efficient or not efficient in terms of memory, right? As long as it, fits and operates, right? Do you really care? Right? Maybe you do if like you're the IT guys and you're using a premium instance capacity and you're trying to, maximize your memory capacity and all that. But if you're on shared capacity, like probably the vast majority of Power BI users, the only people that care about that is Microsoft, right? That Microsoft is like, crap, these idiots, with their single table data models they're eating up like 10 times the space they would if they would use star schemas, and that's costing us money. Right? They're the only people that would care about that. You don't care, right? If your data model has more memory or less memory, in terms of if it's efficient in that way. The only people that care about that's Microsoft, which is probably why they push the narrative of everyone should use star schemas, in my opinion. That's the most logical explanation for that. All right, so let's get back to this article here. So I set up some experiments. So database size we covered. So simple sum grouping by small column. So what I did is I have this report, and then let me get my other one up here. So grouping by small column, in this case, right, gonna have to. So in this case, I used category, and there's only 3 items in category. And let's close this stuff down so you can at least try to see it. Maybe I can make this a little bit bigger. Okay, so there we go. Accessories, bikes, right? So this is grouping by a small column. Grouping by a small column, you see they're identical. I can hit start recording, and I can say refresh and refresh and refresh. And we've got about 2 milliseconds, 3 milliseconds on our DAX queries, right? Which is the only thing that we're really caring about here. So start recording, and we say refresh, refresh, refresh. And again, we have 2 to 3 milliseconds, 4 milliseconds on our columns. But this is, this is all within statistical margins of error here. So now we have a large group column, which is another scenario that he does. And so then we can clear this and say refresh, refresh, refresh. Here we can say clear, refresh, refresh, refresh. And our DAX queries are still in the 2 to 3 millisecond range. 3, 3, 2, right? So doesn't really matter. And this actually confirms like what Marco is saying. And he's got a few more examples to go through, but basically up until this point, up until you get to the year-to-date stuff, he's basically saying, look, there's no difference between flat tables and star schemas in terms of speed and performance, which I would agree with. Okay, so let's take a look at year-to-date. So year-to-date, 5.16 million. Year-to-date over here, 5.16 million. Again, if I do the performance analyzer, 28, we got 4 milliseconds, 2 milliseconds, 3 milliseconds. Over here, refresh, refresh, refresh. Again, 3 milliseconds, 3 milliseconds, 3 milliseconds. So no real difference, right? But here's one of my favorite tests. And this is where I actually have like individual dates, and I'm summing up the year to date by individual dates, right? So you can see how it's increasing in 2010, then it drops down in 2011, and then starts increasing from there. And you get the same thing over here, and the same values basically, right? Same exact values, everything, all that sort of stuff. So now let's take a look at this. So again, I do refresh, refresh, refresh. 21 milliseconds, 22 milliseconds, 23 milliseconds. And then over here, right, I clear this, refresh, refresh, refresh. And you've got 59 milliseconds, 60 milliseconds, and 65 milliseconds, right? So this stuff is twice as fast, 3 times as fast potentially, using the year-to-date calculation on a flat table. Now, you're asking me, well, what's the difference between what you did and what Marco did? Well, this is Marco's calculation for year-to-date. This is exactly what he used, okay, to calculate year-to-date in his blog article, right? I didn't use Marco's year-to-date because in terms of for a flat table, because what he was doing was made no sense from a flat table perspective. So and I was also using calculate, and that it slows things down, right? So this is the year-to-date, and it returns the exact same. It looks, obviously a lot more code and more complex potentially, but faster, okay, on a flat table than the star schema year-to-date, right? This, like, significantly faster, 3 times as fast. So the question, you have to be asking yourself is, do I want my stuff to be 3 times faster or twice as fast, right? And, and do I care? Again, it's nobody's problem but Microsoft's in terms of how much memory this thing's eaten up, right? And you can still get very fast performance out of this. So this is where this significantly deviates away from what Marco was doing in his blog article. I think, again, I account for it. It's not anything that mischievous that Marco's doing or anything else. It's just he's not very well acquainted with working with flat tables and how to do calculations against flat tables. So it's an unintentional bias that he introduced without meaning to, right? And that happens all the time, right? So then, I mean, just to finish this out, right? He had like a small slicer, get rid of that, refresh the visuals here, refresh. So this is basically a slicer on a column that has very few values, right? And then again, we're at 2 milliseconds, right? And the same story over here, right? 2 milliseconds, no difference there. Slicer small that's filtered. So this one actually has a filter on it, which is another example he gives in his blog article. So I can clear this, refresh, 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 right? 2-3 seconds, really no difference. Clear, refresh, refresh, refresh. 4 seconds, 3 seconds. Again, all this within the margins of error. Talking about 3 or 2 milliseconds here, people. Large slicer, so many values, right? So this is based on city. And refresh this, refresh, refresh. Talking 3 milliseconds, 1 millisecond, 2 milliseconds, right? The same over here. Clear this. There you go. About the same. Large slicer that's filtered. Clear, refresh, refresh, refresh. 5 milliseconds, 3 milliseconds, 4 milliseconds, right? Clear first. Refresh, refresh, refresh. 2 milliseconds, 3 milliseconds, 3 milliseconds, right? So no, so in trying to recreate what Marco did in that blog article, one, I think I found a very obvious unintentional bias that he introduced into the analysis, which for all intents and purposes completely changed the outcome, right? At no time is this flat, table with 15 million rows in it versus a star schema with 15 million rows in it. That the at all times a flat table is as fast, if not faster, like significantly faster, is in 2 to 3 times faster, right? So I can't, and maybe if I do some more experimentation around this, that maybe I can, come up with some calculation that, the flat table is worse at than the star schema. But in going through and trying to replicate what Marco's done, I can't produce that. Okay. And I come to a very different conclusion. And this is why, again, I call for transparency around this, right? You can't just put stuff out there like this with zero transparency and no way to independently verify what you're saying. Then at that point, it just becomes an opinion of yours, and there's nothing to prove that what you're saying is actually true, or that you haven't screwed up and introduced unintentional bias into the whole process, thereby invalidating everything that you're saying, right? So again, I said this is going to be controversial, so there you have it. But I went through this with, I wanted to try to recreate what he was saying and correct like what I saw as being obvious problems, like that the fact that this is a 4 billion row back table, which is not the norm, right? So I'm not saying that what Marco's saying is wrong. Should you be building star schemas? Probably, right? But also, are star schemas in terms of their performance overblown? Probably as well, right? Especially for most normal scenarios of Power BI, those are the things that I care about, right? I mean, in the conclusion he talks about with the database size, yeah, that is obviously true. Like it gets out of control when it's a flat table, but again, whose problem is that except for Microsoft? So I don't care as an end user. I can tell you that. How much memory it consumes on Microsoft servers. I'm paying for it, right? So there you go. All right. So that's all I had for this video. Hope you enjoyed it, and I'll see you next time.